All right, so that should be running. All right, so there'll be a competition this Saturday. Last week was SQL injection. This Saturday will be Splunk. It's the last Splunk class, and there'll be a competition using Splunk. Anyway, and a speaker this Wednesday, and another speaker a week from today, and another one Wednesday, May 1st. They're all extra credit? They're all extra credit. Here, everybody is free to come to them all, and it should be good. All right, and let's see if there's anything exciting in the news. This was kind of fun, and that's kind of interesting, in case anybody didn't already know. Well, it's not. This one's fun. All right. And kind of interesting. All right. Well, here's a few ones that are worth looking at. So this is kind of fun. There's the surveillance camera of this Tesla in Shanghai where they make them, and it blows up and burns spontaneously in the parking lot. Tesla has come out and said they're contacting local law enforcement and trying to figure out what happened here. Obviously, they don't much like that. So hopefully they'll figure out what's going on there. Batteries. This is one of the nasty things about the green revolution. If we're going to have electrical power everywhere, then everyone's going to have all these batteries, and batteries are full of heavy metal. The mining required to make the batteries is really nasty for the environment. So, you know, like many things, there's a dark side here. Yeah. Lithium ion, in particular, the strong one. The lithium ion have heavy rare earths in them that are real messy. Lithium isn't, but they also use neodymium and other rare earths, and those things are really dirty to mine. And the lithium itself, I think, actually causes a lot of problems.
Well, I mean, lithium is not very dense to get it from the top.
Yeah, that's right. No, lithium is not dense, but I think I've heard there's lithium poisoning people get. You know,
Don't we give lithium as like medicines to people bipolar?
They do, and in fact, bipolar people that take lithium, in fact, have to take a very toxic level of lithium where it actually has a bad effects on them. That's why they often refuse to take their meds. They have to take them to really, it turns out to be pretty harmful for you. They just, they try to balance the dosage carefully. The range where it has a good effect is very close to their toxic limit. That's why, you know, a lot of people get off their meds and they say, I really don't like these. These meds are really making me feel bad. And they do. Anyway, so Galaxy Fold is out. They're trying to, or to be fair, they give a few samples of this thing. I've heard about this for the last year, a folding smartphone, where you fold the plastic of the screen. And I said, that sounds insane. It turns out to be insane. They made a few models, gave them to journalists, and they broke and quit working within a day or two of normal use. Folding a plastic screen is insane, and it totally self-destructs, of course. You get a piece of grit in there or something. So now they're delaying the launch and trying to fix it. Apparently, this was not ready for prime time. Also, you pay $2,000 for it, and then it breaks after a couple of days of use. That's really not a winner. So people are excited to find out that Apple is spending $30 million a month in Amazon Cloud Services. They're Amazon's #1 customer. Another thing I saw years ago is that Apple stores iCloud stuff on Microsoft servers in Azure Cloud. This is one of the things that people discover every few years and get mad about. Like every couple of years, they rediscover that Tor is a U.S. military product, and if you're using Tor to hide from the government, you're handing all your data right to the government. They rediscover this every few years, and then they forget about it again. And another thing they rediscovered is that Apple can't run servers. Apple used to have Apple servers. They abandoned them. They used to have server certifications. They abandoned them. They can't run a cloud. They can't run servers. They use other people's clouds. Anyway, so they're trying to supposedly develop their own cloud, but they clearly can't build a big enough cloud to store the data they need to store. So they rent it from others. So Russia is trying to have a law, which I'm surprised they didn't already have. I know the United Arab Emirates have this law, and I think Pakistan does, where you cannot have any encrypted channels out of the country. They banned VPNs recently, and they say any service has to have a point inside the country where it is decrypted on the way out. BlackBerry had to do that to expand the United Arab Emirates. Most countries have that, so they can do a man-in-the-middle attack on everyone, and they can identify everybody. And Putin has said, I think 5 years ago, that he thinks everybody on the internet should have a unique identifier next to everything they do, so we can tell who's saying what on the internet. And that will end all this nonsense. And so apparently they don't have that in Russia yet, but they're going to have it. I would have thought they would have had it already, but they'd be like China, where everything is very controlled and very filtered. And I think that's what we're headed for here also. The people that want to end speech they don't like on the internet are also ascending rapidly to power here. So this is actually a very interesting article about the Boeing 737 and how the disaster worked. This is a guy that knows a lot about airplanes. He's also a software developer. So he explained what happened here, which is that to make the airplanes cheaper per seat, they had to make them bigger. And it turns out, this is a well-known fact of thermodynamics, the efficiency of a engine is based on the difference between two temperatures. And the higher the temperature difference, the higher the efficiency. So what you want is you want a big engine that runs really hot to get the most power out of the fuel. And so the original 737 had an engine that was clearing the ground by maybe 10 feet here and below the wing, but the MAX had to have a much more powerful engine. And to make it more powerful, it wouldn't fit. The wing wasn't far enough from the ground to keep it off the ground, so they had to move it forward and up. And that had the effect that the power now causes the plane to tilt up. And he said this means that when the plane starts to get the wrong angle of attack, it will increase that effect, lifting up like a helicopter, becoming more unstable. And that is forbidden. He said the only kind of planes that are allowed to have this unstable condition where when they start going out of their optimal angle, they get worse, are fighter jets, and they have ejector seats because they do go out of control, you're screwed, and you jump out. You're not allowed to have those in passenger jets. But they designed this thing in such a way that it's unstable, and to save money, instead of fixing it by redesigning the plane to move the wing to another location, they added software to compensate in software. And the point is, the selling point of the 737 is that if you buy a new model 737, it is legally considered the same as the old 737, which means all the regulatory approvals still account, and all the pilots that you've trained are still authorized to run it based on their training of the previous 737. So they can't admit that it's different and call it a different plane without having an enormous expense, and their customers wouldn't want to buy it anymore. Because to save money, the fleets, the airlines all want to have a fleet that are all identical, and they want all their pilots to be identical, so one pilot can drive any planes. They want to have one set of rules, so they pretended that this is the same as the old 737, but it isn't. And that led to this situation that's very interesting. Anyway, all right, so I think that's enough, and we'll carry on with cross-site scripting, which is what we're up to here. So bring that up. All right. I see a chat message coming in. For SQL PHP injection, if a web application lets user input database, is it possible to inject SQL or PHP code? I do not think so. I see a PDO connection here. I'm not sure I know the exact syntax, but the PDO connection you're showing there looks to me like the stored procedure type of PHP to reach to SQL, and that is, I think, not injectable. In fact, let me just bring that up. I thought I had that in the projects. Let me see if I can find it. There should be a SQL injection project, and there should be some example of the right code to protect from it in one of these. Let's see. I've got too many SQL tutorials, and I don't know. All right, let me try and find one that shows you an example of the right code. Maybe it's one of these. Not one of those. All right, I've got to deal with this Zoom thing being in the way again. All right. Gotta try and get this garbage off the screen. Zoom really likes to fill the screen with garbage. All right, and there we are. Somewhere at the bottom of this one is the check proving MySQL. Well, maybe I cannot find an example of the right. There we are. I think that's one type. There's a better defense somewhere, but I'm afraid I've lost it. I had it years ago in my previous generation of this stuff, and I think I can't find it in a hurry, an example of the right code. But that stuff you had looked pretty good. Somehow I can't bring up the actual code, the PDO stuff. But that looks pretty good, what you were posting there. Is it possible to inject SQL or PHP code? You got it, right. Anyway, let me put up this example you had. That's about as close as one I've seen of the right example. I used to have it in the projects in my 123 class, but I haven't taught that in a while, and I don't know where in the world it's ended up. But here's the one he had. This looked pretty good. You have something like this. The way I did it, it took about 7 lines, but you use this PDO connection to the database, and now you have username and password passed in as separate objects. And I think I had it in the slides in the previous chapter, an example of the right thing. The point is you don't have a line of code with apostrophes and data from the user just put in a line and then parsed. So even if there's an apostrophe in the username or the password, it won't cause the computer to get confused about what part of it is code and what part of it is data. Some structure like that is the right chapter. Is the right structure to avoid SQL injection. Anyway, see if I can somehow get all this junk off my screen. All right. All right, so let's talk about cross-site scripting. This is actually, in my opinion, a diminishing problem because people are finally blocking it in the browsers, which is probably pretty effective. And that's why when you do your projects here, you've got to use Firefox because almost all the other browsers block cross-site scripting now. So the point is cross-site scripting lets you take some place where you should only be putting static text, and you can put in script tags, which the developer did not plan for. And this means other people will see scripts that run in their browser when they view the text you put up. This is the most prevalent app vulnerability in the world. The textbook says more than 90% of all apps have this vulnerability. It's certainly a lot. So here's the common types. Reflected SSS are where you make a crafted URL that includes script tags in the URL. And when people click on it, they see the tags. So if you go to the demonstrations here, I've got XSS demonstrations. Here they are. All right. So here's a simple example. If developer is drunk, you submit and it prints developer is drunk. This is very common. If there's anything like a search engine on a page where you put in text and the result has that text on the page, you often have cross-site scripting. So if you put in a script tag, all right, and then run that, it will now pop up a box. Now, this is what people usually do to prove it. Popping up a box is not a risky thing, but it demonstrates that I'm able to run scripts. So the tag that I typed in up here, which you can see in the URL, script alert something, made this tag pop up, and therefore I could have run any kind of JavaScript in the person's browser that views this. Now, in this case, I'm just running script on my own machine, so I'm not doing any harm. But if I go to some message board where I can store data, then I can affect a lot of people. And even if this is the only kind of injection I find, notice when I did this, there's a URL up here. And that URL includes the script tag. So I could take this URL and email it to someone. And if somebody clicks on the link, it'll run that script. And that's what you do. And you could put it in one of those URL shortening services to make it less obvious. And that's what a lot of people do. So then it's just a matter of social engineering to trick people into clicking on that link. All right, so the thing that prevents you against this is called XSS Auditor. It's built into most modern browsers, but Firefox doesn't have it. That's why Firefox is the browser to use if you want to practice elementary cross-site scripting these days. This and plain text password sniffing are both on the way out because of browser improvements. Now browsers are warning you more and more if you're putting data into a form that is not secure, and they're more and more blocking cross-site scripting. So that seems to be the effective defense. So reflected SSS, like say the attacker has to make, the user logs in, the attacker feeds you a crafted URL, because remember, once you log in, every further request to the same domain will send your cookie. And if I can get your cookie, I can log in as you. So I have to wait until you've logged in, then I need to feed you a URL, which appears to go to the same domain, but it runs a script that sends the data over to me, and then I can steal your data. I can hijack your session by having the cookie stolen from your machine. That's typically how it's done. I see another chat message coming in. What's the reasoning? Firefox doesn't include it. Oh, you got me. I don't know. I know in general, Firefox is more concerned with obeying standards. I don't know exactly what goes on. I know Firefox is actually a open source nonprofit democratic institution, so they have like a forum and people argue about things. So decisions are made in that fashion, and I'm sure you can read many pages of forum posts of people deciding why to do it this way. But in general, the main thing that seems to win is obedience to standards. But it's a good question, and I don't really know. Anyway, so they create a malicious script that will now take the cookie and send it somewhere else, and you'll see that later. So if you have a persistent cookie, which is what almost everybody has, especially on mobile devices, because they don't expect you to keep typing your password in, then I can just trick you into clicking on a link, and I'll get your cookies, and then I can be like you. Now this is, yeah.
So does Firefox not follow this site only cookie flag, or that would stop cross-site?
This site will what?
Like one of the flags you can set for cookies is that it can only be sent to this specific site.
Oh, they well, no, I don't think so. Well, yes, the flags you have for cookies are secure and HTTP only. In general, cookies are supposed to always be sent only to the first site. Yeah, you can set those flags, and every browser will honor them, but you have to set them. They're not on by default, not in any browser. As far as I know, every browser honors them if the developer puts them in. Of course, what the developer ought to do is have CSRF defenses so that the cookie does not uniquely identify you. The cookie should include something like your IP address, so that it will only accept a cookie if it comes from your machine. And if someone steals your cookie and tries to use it, it shouldn't work. All these are easily prevented if the developer is aware of it. But most developers are not, and most sites have no defenses, which is true of almost everything here. Most of these defenses, just like most of the problems in the world, are because people do something stupid that everyone knows they shouldn't do, because they're just busy or lazy or, it's not like, just like SQL injection, the solution's been known for a long time, but a bunch of people don't implement it. So anyway, let's dig in now. Stored SSS is the bigger one, where you store something like on a Facebook post, and now millions of people will see it. And so you have a vulnerable message board, and you can stick a script in the message, and everybody that views the message board will have that script run. These are the big ones. So in a stored XSS attack, you store it up there, and now everybody that views that, you get their cookie. There are a bunch of these. And the third type is DOM-based, document object-based model, which is just another way to do the same thing, but instead of just putting the script tag directly in the URL, you put it somewhere else on the page. Now, this is from a modern kind of page, which uses part of the URL and displays it on the page. Now, the one I had here did something very simple. It had a parameter up here called message. Message equals developer is junk script stuff, and it just takes whatever the message is and puts it here. DOM-based XXS is just a generalization of this. In principle, with JavaScript, you can refer to any part of the page and use it to develop another part of the page. And there are a bunch of active pages that do use JavaScript to take data from somewhere like a URL and put it on the page somewhere. So it's just a more general situation than this simple one where the message is sitting right there and it gets put in the source code. It's where any part of the page is calculated from stuff that is controllable by the attacker. So the developer can put a script there and it will appear. And so here's, for example, a dynamically generated error message. I'm going to have a script which takes the index of message equal and writes it here. It takes something to say, for example, the SQL errors. SQL errors say there's a SQL syntax error near this line, and then it prints a line. So it takes data from elsewhere to build a line. So these are the general principle where something that came ultimately from the attacker is showing on the page. And there's an opportunity for cross-site scripting. So there's a DOM-based XSS here, which is very similar to the previous one. You have a message up here, and the message just appears through the JavaScript. It amounts to essentially the same thing as reflected SSS. So let's take a look at the first cahoots, which should be open somewhere, but maybe I've lost them. Apparently I've lost them. All right. Should I operate my computer?
I like the cat one.
Cat one? Well, I don't remember that one. Yeah, yeah, there may be. Yeah, yeah.
No. Believe it or not, I do not put all the cats on.
No, there were some cats I actually put in the projects, but I forgot. Yeah. All right. That's good. Well, she put them up for sure. Let's see the wrong way to do it. It's this way. There we are. Good. And I have a place. Store the results. All right. There.
Where are these other people coming from?
On the internet, they're connecting with Zoom. We've got some large number of people here, like 8 people connecting over the internet.
So there's like an online class?
Yeah, you can just connect on Zoom. The link's been on my page. A lot of people watch it by live cast from elsewhere.
Oh, wow.
All right, guess we're going to go. I'll give it another few seconds to see if anybody joins. All right. So what's the most prevalent vulnerability? All right, of course, cross-site scripting. So in a search page, the script in the query string runs on the result page. What is that? Okay, that's reflected SSS. You could, for example, see it right here in Kahoot. Here's a quiz ID equals something. If you were to inject a script tag there, it might show up on the page. I don't think it will. But if Kahoot was vulnerable to cross-site scripting of this type, it would.
It definitely was with the usernames.
It would?
It was with the usernames when I was doing research.
Well, when you put it in the username, it just printed the script tag.
It used to not do that. It used to actually.
You used to actually run the script? Oh, that's awesome.
Yes, yes.
Oh, that's awesome.
They fixed it, unfortunately.
Oh, yeah. Well, good, good. That's cool. Right. So what attack steals session cookies? Right. They all can. They all are capable of doing this unless you mark those cookies HTTP only. You can send them to another site with JavaScript, and that's often how attackers do it. What attack steals all the data in the database? Okay, none of these can do that. That's SQL injection. This is why most people don't fix cross-site scripting, which is why it's the most common vulnerability. It's a similar error as the error in SQL injection, but people don't care because it's not as dangerous. It just allows one user to hurt another, but the company itself is typically not compromised, so they don't regard it as a high priority vulnerability, and they often just leave it alone. So anyway, let me record the winners. All right. Type confusion will have to tell me who they are if they want their points. And Caitlin, I can tell. All right. And let's carry on here. So here's some real world attacks that led to all this. Apache had one in 2010. This is quite common. There's a product called Elma, which you used to be able to find easily, which was a log aggregator for Windows-based systems, and it was often publicly available. Toyota was vulnerable to this. You could go to the Toyota Elma server and see all the errors from their web server. So all you had to do was send somebody a link with an extra apostrophe in it going to the Toyota website, and if they were logged into Toyota, it would post their cookie and open available web page. There's a common flaw. And so there was a similar problem with Apache. At the issue tracker, where you could post complaints about Apache software, that you could inject cross-site scripting. So somebody put up a code that would steal a cookie, and he got the Apache administrator's cookies and was able to then alter the Apache source code and put poison in it. This happened many times. This happened to Mint Linux about a year ago. It happened to a major library about a month ago. It happened to a major Python, PHP include library a while ago. This is why people who use open source are unaware of how many other people you're trusting. And frequently, one of those many people that wrote some of the libraries that your code is using have been malicious or hacked. Anyway, it happened to Apache, and that's the aim here. So now he was able to steal passwords or cookies from people and compromise those systems. MySpace was the most famous one. Sammy Kamkar did this one. Yeah, okay, here comes. Is the best way to get users like an admin to click on infected URL XSS through phishing? Well, that's a very good question. We'll talk more about this, but the most common way is phishing to attack companies. But probably the watering hole attack is better. If you have a group of people, a watering hole attack is what they did here. They would then find a page that they're going to look at eventually and just put poison on the page and then wait for them to look at the page. That is probably more effective because a lot of people know to be worried about clicking links in emails. So you're only going to get the low-hanging fruit that way, but everyone has to look at the page. So but those are the two main ways. Phishing is the most common, and watering hole is probably a higher level one, where you poison a page that you expect them to look at. All right. So MySpace made public awareness of cross-site scripting happen. MySpace was before Facebook, the #1 social network. Everybody was on it, and they were vulnerable to cross-site scripting. So Sammy Kamkar was able to add JavaScript to his profile, so everybody that was his friend or that saw any of his posts would run the script, and the script would add him as your friend and then put a copy of that code in your profile. So everybody that saw anything you put up would now add him as a friend. So in like a few hours, he had 1 million friends. Everybody on MySpace was now his friend. And that was pretty dramatic. It went around. After this, there were a whole series of Twitter worms that would crash your machine or do something ridiculous and fly around for the same way. All the social networks fell for these things. Strong Webmail was one of the first companies. You may remember there was a guy that ran an identity fraud prevention service where he claimed that it was perfectly fine. He actually published his social security number saying it would be fine, and he got like hacked like 7 times. People stole money from him over and over again because his own product couldn't save him. The Strong Webmail invented one of the first 2-factor authentication webmails, where not only do you need your password, but you also get like an SMS. And he made the same thing. He published saying, I'll pay $10,000 to anybody that can hack my mail. So of course he totally got hacked. Never do that. No matter how smart you think you are, never invite everybody to hack you and say they can't. You can have a bug bounty and say you'll pay them something to tell you if they get in, but don't pretend that people can't get in. They can get in no matter what you do. Anyway, what he did here was he had a stored, they downloaded his product and tried using it, and they could see that just like all of them, you don't always want the stupid phone ringing every time you log in. So there is an option to not keep calling me for this trusted computer, and that's implemented by storing a cookie that says this computer is trusted. So they just found a stored cross-site scripting, and they sent him an email that said, we have hacked your email. This PDF document proves it. When he opened the PDF document, it then ran a script, stole his cookie, and sent it to them, and now they were in his email. So it was kind of funny. They lied, but by him opening it, they were not lying anymore. They got in. So that's how they won the 10,000. Yeah.
The guy giving out the Social Security, I think he's still doing the same thing.
Yeah, I think they got the Social Security. There's a bunch of people. And there's also, John McAfee did this. John McAfee made a Bitcoin wallet that he tried to sell people that was just a cheap Android phone with some software on it. He claimed it was totally unhackable and claimed he would give you $1 million if you hacked it. And all these people hacked it. And then he said, oh, you didn't really hack it the right way. What you did didn't count. He didn't ever pay up. They usually never pay up. It's usually all just snake oil. But anyway, then a bunch of Twitter worms went out. I saw a bunch of these. I've been using Twitter a lot, so I saw these go by. There are various worms that would get people to go to places. All right, so anyway, you can do a virtual defacement on a website. You can make a link which loads a web page and adds code to the page. So this is pretty easy to do with reflected XSS. You can, for example, I can just say our business was acquired, and I can add scripts up here. So I can say our business was acquired, please go to our new page. You can add that if you can add scripts. That might fool people. And sometimes you can even add code that causes the original page to not show up anymore. So you can add a fake login form. Here's one that added a fake Google purchase form. See, if you look up here, it's google.com, and then you just have a long bunch of junk up here. And that long bunch of junk decodes into this page. So now you're going to a page that is really on google.com, and you're seeing a page that looks like a Google.com, but it tells you Google is paying because now changed to a subscription service. You have to have your credit card, just your Gmail now. And you might fall for that. And you can do all that because of cross-site scripting. That's why they pretend it isn't a big problem, but it can be used to do a lot of harm. And one of your clues here is this big scroll bar. The real page is way down there somewhere. But there's also techniques where you can make the original page vanish entirely. Anyway, so if you do this, where you send out a link and people click on the link and you get their cookie, you're only getting one cookie at a time. So this is kind of expensive. This is something you do for a targeted attack like a penetration test. It really isn't something you do if you want to attack a lot of people at once. It's kind of labor intensive. So you have to induce user action. You have to trick them into clicking on a link or something. So you aren't going to get an administrator account unless you can trick an administrator into making a mistake like that. All right, another way to do it is trust relationships. Your autocomplete can fill in things, and it will then send it to the same website. So if I can confuse your web browser into thinking you're still on someone else's site when you're actually sending data to me, then they can run code. And so ActiveX was one of the early ones exploited. This was Microsoft's attempt to run compiled code. It was spectacularly insecure, and there were a ton of ActiveX exploits. I think ActiveX is pretty much gone now. It was Microsoft's big thing, and it was their competitor to Java. And both client-side Java and ActiveX have pretty much fallen into disfavor after about 10 years of being a wide open door for everybody to hack everybody through them. Right, so when you can attack users in more ways. You can port scan the local network from the browser to some extent. You can log keystrokes that happen in the browser. There's other things you can do in JavaScript. So let's take a look at another set of these things, which is 12B. All right. And there's a tool I used to have in this class called Beef, that the browser exploitation framework that injects JavaScript. It turns out most of those attacks aren't very exciting anymore. Most of them got patched, so I quit using that tool, but it was kind of fun for a while. I like the rainbows. How do you do that? Just what's that?
The emoji keyboard?
There's the emoji keyboard? Okay. Yeah. Good, good. Well, that's cool.
I did.
I'll give it a few more seconds. I guess that's it. Oh, okay, here comes some more. All right, I guess that's it. Okay, which one earned somebody $10,000? On webmail, I think he actually paid up, unlike most of them. Which one did Sami Kamkar perform? Was the thing that made him famous. The MySpace hack, he's done a lot of things since. He's invented a lot of tools. He's gotten in a considerable amount of legal trouble too. He pushes the limits too far occasionally, but I don't think he actually got a prison sentence. I think he did get lesser punishments a few times. Which attack gained administrative actions? That was Apache. They're actually able to poison the source code. Which one is labor intensive, where you have to steal cookies one by one? Oh, that's the one they described as session hijacking. I suppose you could, in principle, automate it, but it's not usually done that way. All right, so Mateo and Caitlin have won twice each, and someone's using fake names, which is currently permitted on the internet, although it will impair my ability to give you points. Let's see if someone's coughing up names. Ah, good. Okay, good. I got a real name for I. All right, good. All right, good questions. I see them going by, and there's a little more to talk about here. So, all right, delivery mechanisms, which we've already had a few questions about this stuff, which is the point. The simplest, most common technique is a phishing email containing a URL. You trick people into clicking on that, or you send an IM through some kind of chat message like Twitter or something, or you can put code on a website where people can post an HTML like a Facebook wall and put it there. The watering hole attack is the other one. This became famous in one of the early attacks of the Chinese government against Tibetan rebels. The Chinese government is famously, fantastically ruthless against internal protesters. The protest to government, like Tiananmen Square protests, and in particular the Tibetan nationalists, they're really, really nasty about crushing the Tibetan religious minority, and there are people who very strongly protest the government's actions, and so they wanted to spy on them. So they put up pages about Tibet, and they put malware on the pages that would affect people, because they knew the activists would go read those pages. And that made people aware of the watering hole attack, where you often write a page just carefully designed to attract the people you want, and then you put malware on that page. Yeah.
Who do you think has better hackers, the Russians or the Chinese?
What has been said, the number one hackers in the world is the US. We're the main aggressors, just like other military things. But between the Russians and the Chinese, what I've heard said by the experts, not that I'm an expert, is that exploits are developed in America, and then they are taken to Russia, where they're used to make money by the criminal gangs who want to steal money. And in China, they're used for political purposes, not directly to make money. Although in China, their big hacking campaign for the last 10 years has been an official, public, sponsored campaign to steal intellectual property from the West. Patents and copyrights and technical things. That's why they have Chinese knockoffs of everything, because that is their official way to improve China, is by imitating our technology, by stealing it rather than paying for licenses. That's been their official government policy. That's what they've been doing, and also bald-facedly lying about it when they get caught. And we have not done much about it, although now Trump is trying to punch them back in various ways. So,
isn't their military kind of becoming more intense than ours?
oh,
Like their
gee.
Navy is taking over the Southeast Asia.
Well, I don't know enough about that. I'd be surprised if their military is ahead of ours, but they certainly have a lot of 0 days. Their cyber attacks are very sophisticated. They are the original APT actors that took over all our companies, and they've been very effective. I don't know if they're more effective than us because our stuff are made secret better. But from what's come out, they're very big. The Russians are not as dangerous as the Chinese, I think, although they're getting pretty dangerous. It's hard. It's a good question. I don't have a simple answer. And by the way, everything I know is from the public exposed things, and that is probably almost all lies and cover stories. So we really don't know. There's 34 known APT groups that the main attacks are done, and that's what they call them, the Advanced Resistant Threat Groups. North Korea, Iran, China, and Russia are the big ones, but there are others, like Estonia and such. Anyway, all right, so you can have, you make a page, it's got some kind of malware on it. One of the simplest ways to do this is to just buy an ad. If you buy an ad, ads are not loaded. If I put an ad on, say, Facebook, that is not loaded from the Facebook server. They just take like a square inch of material and they load that page from another server, which the advertising network controls. Typically, the company like Facebook that's delivering the ad does not even know what the ad is going to be. They just make a deal with some kind of broker who agrees to get them customers to put ads up there. They don't even know what's going to be there. So you can put up an innocent ad and then change it to a malicious ad later. And you can just pay for the ad with a stolen credit card that will bounce later. And people do this all the time. This is a very common way to get an ad up. You can typically get about 10,000 people to view the ad and get infected before they'll catch you and bust you. So it's a game. Now, you can also use the tell a friend feature, tweet about this inside a website to send a message about a site, and that might have a cross-site scripting vulnerability, so you can send messages from their site that will attack people. And so this is in-band to deliver a stored attack where you put up the names of files, some kind of message that's on the server. So they're really going to the real server, and they're getting data that you put on the server, because servers have a lot of data that comes from their customers now, even under normal circumstances. But there's also out of band, where somehow you're doing something other than viewing the app directly, like reading an email. Typically, cross-site scripting by itself is considered a low vulnerability because it doesn't directly get you into the server. But it's often part of other attacks, like that strong webmail attack. The cross-site scripting did not mean they could read his email, but it was used to steal a cookie, which made it possible to read his email later. So here's one where cross-site scripting allows you to insert into a name, like Caitlin was doing with Kahoot. So if you can insert something into your name, then then he found a flaw that let him change other people's names. Now he could put a script in everybody's name, and now everybody's going to see this, including the administrators, and eventually you get administrator tokens. So if you want to find these things, you can inject something like this. Like this, what people usually do, script alert, document cookie, and stick it everywhere and see if an alert pops up. That's one way to do it. That won't find them all, but that's the most common demonstration. Now, there are attempts to prevent cross-site scripting, like things that will just try to remove these characters or the script tag so that you can just make modifications of it. You can encode the less than and greater than sign with HTML encoding, and that may cause it to script through the filter. You can mix uppercase and lowercase letters, and there's many, many other tricks. Sometimes the reply is sanitized. So one thing you can do is insert a benign alphabetic string, just look for that alphabetic string coming back. You can program this. So you can put a word everywhere in every field in an automated thing like JavaScript, like Python or Burp, and then look for any response that contains the word you put in. And each of those is a place where you might be able to inject code. So you should inject a unique string like this, my XXX test, and a few random letters, and then you write code that looks for that coming back to you from anywhere on the server. That would be a way to find any place where the data appears to contain what you put up there. And then you test these to see if there's exploitable. It's probably something you have to do manually. Vulnerability scanners will attempt to detect this, but they're typically very ineffective at finding it. So there are often cases like this where you can put in something like height and width at 50%, and that's going to be inside an image tag, but still I can add scripts there. I just have to put a closing tag in the percent and add an extra tag in the middle. And if data from the user is used anywhere in the HTML, you just have to understand where it is and figure out how to make the syntax so it'll work. So if you have a value, and I have value equals my XXSDM, so the data I put in is inside the quote, inside the tag, that means I have to close the quote and close the tag, and then I can put in a script. So, all right. If it returns this kind of thing, where I've got a variable inside a script, then I can just put a semicolon and another command inside the script, and it'll run. And if I have an attribute inside a URL here, then I can insert the JavaScript handler inside there. So there's a lot of ways to do it. The JavaScript, you can, by the way, in case you don't know, you can put JavaScript right up here. You can go JavaScript : alert 1, something like that. I think it'll work. Maybe not. Maybe I need to put script tags around it. There's a way to run JavaScript right there. Maybe somebody knows it better than me. You have to put in script tags. I thought that would be unnecessarily redundant. But this is Firefox, so it should work. But I am not getting it right. Anyway, there is a way to put JavaScript right there. I don't know why I'm unsuccessful at doing it right now, but I'd have to go Google it and find the right format. But JavaScript is a protocol just like HTTP, and you can do it right there. JavaScript alert 1, that should have worked. What did I do wrong? JavaScript alert 1 should have worked, but apparently I fouled it up somehow. Yep, all right. Anyway, all right. It'll work in on-clicked anyway. All right. And so here we have it going into a parameter. All right, we've been here before. All right, so if you want to probe these filters, here's types. You might have a web application firewall, which recognizes a signature and then throws away your input. Or in that case, it's hard to defeat. Then you're going to have to avoid triggering it. That would be the safest. However, what they usually do is accept your input, try to remove the malicious part, and pass it on. That's sanitization, and that makes it a lot easier to get in. Another thing they might do is just truncate the length of your input, which is a simple control. So to beat these things, if you see an error message here, a potentially dangerous form is detected, that means you got caught by a filter, so you're going to have to not trigger it. So you just remove parts of the string until the error goes away. We see a lot of these at college, by the way. College has a high-level attack filter, and a lot of my projects set up the filter. That's why you often have to go off campus or use danger zone to do your homework, because the college firewall blocks it. And you'll often see messages like this. So our system is a pretty good one to practice on. Anyway, so you remove data until it no longer triggers the error, and now you know what the problem is, and then you can try to just change it to sneak it in. So you can try to put in your script tag somewhere else, like data equals data text HTML, just another place to hide it. You can encode HTML as base 64. That's valid. It'll accept it. So that'll probably bypass the filter, but the browser will unbase 64 it and run it. That's another way to do it. So here's one that blocks script tags, but you can sneak in script tags by base 64 in them. Other techniques. All right. There are event handlers. These are ones that run without user interaction on ready state change, on error, and so on. There are all these are event handlers. This is a JavaScript has the ability to add active code inside a tag without being in a script tag. If you can't inject a script tag, you can still put on something like on error, and then it'll run that script when some kind of error happens. All right, there's autofocus. This will run when it'll automatically move the cursor to that event. That's the autofocus. And on blur, this will take effect when they click on anything else on the page and quit focusing on that, and so on. This will happen when the mouse moves. There's just many. You can also put in a tag. There's new tags like video that don't always work. And here's another weakness of HTML. HTML has many versions, and browsers have many versions. So you can put a tag that is nonsense in a page, and browsers will not regard it as an error. They will just assume, oh, I must be an old browser. That must be a new tag I don't know about, and just try to ignore it. So you can use that. So you can put in pseudo protocols like embed and such. You can. I used to allow VBS. I don't know if it still does. That's Visual Basic Scripting. Yet another way to put active script on a page. HTML5 gives you some new techniques to add data to a page. And there's more ways to do it. Here's ways to obfuscate an attack. You can just use capital letters. You can put null bytes in this way. Now, the point of a null byte is it will terminate a C string. And what you're hoping is that the firewall was written in C, which it usually is to make it fast. So it interprets this as the end of the string and doesn't look any further. But the browser sees it after further clearing up and doesn't stop at the null byte. That's the game. This commonly happens. You can put in, there's what I was saying before, you can put in an invalid tag. You can put in an X tag, which is not a valid HTML tag. But the browser will often just assume, I just don't know about that, but I know what on-click means. So when you click on that, do something, even though I don't understand the original tag. But the original tag might be enough to confuse the web application firewall, which will not regard it as a script tag. You can change the base. People put in incomplete URLs like this, run goodscript.js. You didn't say exactly what server to get that from or exactly what folder to get it in. So if you don't specify, it goes from the base href. So if I can inject a base href tag, which is not a script tag, I can cause the loading of a script later to load from the wrong server. And now I'm injecting my code into your page without ever putting a script tag, even if I can inject a different tag. You can put spaces after the tag name. Like people might look for this alert and expect a space. So there are ways to write things without a space in them. You can add extra characters like slash and such to separate words, and browsers will often accept that. You can put null bytes in the attribute names. You can use backticks instead of apostrophes and quotes, and browsers will often take it, but the preprocessors will often be confused by it. This is the fundamental problem with HTML. HTML is very, very insane. I was horrified when I first started learning HTML. I came from the world of Fortran and BASIC and C. And there you have to write a program, and if there's any mistake, it won't compile and it won't run. It says error in line 41. You have to fix that error. I'm not doing anything until you fix all the errors. HTML is very, very much not that way. You can have errors in your HTML page, and the browsers will still run it. The browsers will try to guess what you meant, and they will try to fix up what you have. And the reason is because the web is all full of sloppily written code from decades ago, and people want to be able to see it. So it's not okay if somebody puts an extra apostrophe in the page for the browser to just go, blam, this page is broken, you can't see this page, tell the developer to fix this page. That's not acceptable. It tries to guess what was meant and show what, as much of the page as it can, and that means you can get away with murder. So you can put in weird broken junk, and browsers will often try to fix it. And they will all make different decisions about that. So pages look different in every browser, and it's a nightmare for security people. It'd be nice if there was just one way to write a script tag, and I could write a filter that looked for that one thing, and when I don't find it, I know there are no script tags in there, but that's very far from possible. There are so many ways to sneak in active code. I'm amazed. When I got in this business like 15 or 20 years ago, one of the first lessons I heard was they said, Microsoft is evil people polluting the web because open source people have a simple rule. Text files are in one kind of file and script files are in another kind of file, and they never mix those two features in the same file. And that way you know where the active content is and you know where the passive content is. And Microsoft Word is the horrible bad thing that mixes script tags inside a document tag, and that's what ruins the security of the web. And I believed that for a while, and that is such garbage. HTML is the king of mixing active and passive content together in the same file to where you can't even tell them apart. And it does make a nightmare, but that's where we are. Anyway, so you got delimiters. Here you got source equals A and then on error equals alert, but you can put in one with no spaces by just putting in extra tags. All right, we talked about nulls. You can use HTML encoding. You can use numbers to refer to the forbidden characters, and they may not be caught at the filter. There's just so many ways to sneak things past. Some applications perform URL decoding twice, so you can doubly encode it. %25 will turn into %, %3c will turn into less than. So this group of 5 characters is equal to a less than if it's doubly decoded, and some systems did that. There are also foreign languages. If you have Japanese or Arabic or something, then it doesn't fit in 1 byte. So you have this Unicode encoding, these long byte, multi-byte codings. There's Unicode and there's other ones, UTF-8. So this %U then has 4 hexadecimal characters. This is a 16-byte character, which stands for 1 character. And you can put normal English characters in there, but there's a whole bunch of other characters. Like there are these weird things that are not like less than or greater than, but they look like it. And some browsers will accept them as less than or greater than, because they will try to clean this up. And you can put in extra brackets often, but the filter might not catch it. And this weird thing, Firefox will accept, even though it doesn't make much sense. There's a lot of things like this. You can, there's a thing called a web developer add-on you can put in, which will try to show you the generated code after Firefox has tried to fix it. So you can actually see what all this cleanup attempt has done for at least Firefox. But every browser maker makes their own code to try to guess what the developer meant and fix broken code. So here's UTF-7, US ASCII, UTF-16. This is one that has 16 bytes. So that if you write normal English, there's a 0 in every other byte. But for other languages, we'll use the other byte. So you can set the character set various places in a web page. That tells it how to interpret the data it sees. There's a thing called Shift.jis, which is a 16-byte intended for Japanese. And this means I can inject %F0, and then the next byte will be interpreted as the rest of this character. So I can, if I can inject something, I can chew up the next character that the developer put there. So if my data goes in quotes, I can put in this, and I can chew up the second quote and make it vanish. That's pretty awesome. All right, So then there's a way to, here's what Unicode would look like, \u. There's the eval function in JavaScript, just like there is in PHP, where I can evaluate strings that will turn into text. You can put in extra backslashes in the middle of things, and they're usually harmless, but they might confuse the filter. You can use A to B and B to A for ASCII to binary and binary to A. So now you can put in base 64 and it will run it through this to turn it back into code, and the other way. These are commonly used, and it's just another way to sneak in data so it doesn't look normal. You can dynamically construct strings. I see this all the time in PHP malware. It will have a string that's just 100 random letters, and then it will take letter number 41, letter number 20, letter number 15, and that spells out JavaScript do something. You can just build code in a way that it dynamically creates the code, but a scanner will not find that code in there. It has to run the code to create the code. This is called self-modifying code, and it's been forbidden for computers for decades. I used to write this stuff years ago, and I wrote an 8-bit assembler, but you can write code that dynamically modifies itself in higher-level languages like JavaScript, and they allow it. And it's considered completely insane and evil because you can't even print out the code and audit it. You can't even read it. You can only find out what it does when you run it. But it's a way to hide things so people can't easily steal it, and people and security products can't detect it. I think I saw a chat message go by. The coolest I've seen on this is an Amex credential stealing fishes. JavaScript builds the entire Amex login page. Oh yeah, absolutely. You can totally do that. And there's also HTTP response splitting. If you could inject carriage returns, you can take one HTML response and split it into two. So there are two web pages coming from the server. And now they'll only see the first one and the second one will vanish completely. I mean, it can totally be done if you have the ability to inject characters. So here's eval showing this thing where it's going to replace these characters with eval, taking data and loading it. I'm not going to worry about it here. But anyway, that's the point. All right. There's a lot of these until it gets sort of maddening. Your book talks about VBScript, which used to be hot, but VBScript, even Microsoft has abandoned VBScript. It was their competing product to try to put JavaScript out of business, and even Microsoft's given up on it, so I'm not going to worry about that. So if you want to beat sanitization, you can HTML encode things. This is what you should do on the way output. The best cure for cross-site scripting has always been output encoding. Rather than trying to catch all the bad things on the way in, the best thing is when you actually print something out to the next customer, sanitize it. HTML encode it. So whatever is up there, any less than or greater than signs, just turn into visible less than or greater than signs, which is what happened now when she tried to put a script tag in the name in Kahoot. It just prints script there. That is the only place where it's considered effective, is on the way before you show anything to anybody, encode it. And then even if somebody stuck in scripts, it doesn't matter. That's generally considered the best defense against cross-site scripting. All right. You might already be injecting into a script, so you don't need the script tag. That's a good one. If your script remover doesn't remove all instances, you can just put in two script tags, or one inside another, and their sanitizer might just remove one of them. All right. And even if it does two passes, this one, first it removes script, then it removes object. So when it tries to remove script, script is not there. When it removes object, what's selected is script, but it thinks it's already done removing script, so I get to sneak it in. This sort of thing will slip past. If I control something inside a handler, then I can put in an attack string in there. So anyway, if I have short attacks, this is a fairly common one you see in CTFs. You have a short thing, like only 10 or 15 characters, and you have to somehow sneak in code. There are ways to make these things very short. There's websites full of the shortest possible injection to do something. All right, here's a JavaScript packer that will just try to compress JavaScript. These are commonly used just to make web pages load faster. If you have a ton of JavaScript, you pack it just to make it come down. All right, if you have multiple injection points, where I have page ID and seed and mode, and I'm able to inject to more than one point, I can put a part of the script in one inject and part in the next. This is another way to defeat length limits. So if I have three hidden fields here, page ID, seed, and mode that I can change, I can put in an injection here, part of a script here and part of a script there, and I can put in comment tags, which is /* and // so I can cause it to ignore part of it. And we saw examples of this before. If you have multiple injection points, you can span them together. So here's the result. The bold stuff survives, the unbold stuff vanishes. So I'm able to put in alert document cookie and cause all the unnecessary code to vanish behind comment tags. You can convert to DOM object model. If I can inject JavaScript, I can inject, this will evaluate the fragment string, which is the part of the URL after the pound. And I can steal that if that's what I want to get. All right. This one here, HTTP, is interpreted as a code label. You know, I'm not going to, there's just a million ways to do it. And trying to write filters that will stop it all is sort of mad. Which is probably why there's so much cross-site scripting out there. All right. So I got another Kahoot about this stuff. I guess that's a hamburger or something. Huh. I remember there was some huge argument about the hamburger and sushi emoticons. I saw angry people about this. I'll wait another few seconds. Looks like that's it. All right. So, one attack posts a malicious page, and you wait for the targets to visit it naturally. Okay, that's watering hole attack. All right, what attack puts the first part of a 16-character construction in there to remove the next character? That was the Shift.js for Japanese. All right, what character may cause a filter to stop working? The null byte may be interpreted as a terminator. All right, what function decodes script written in base 64? That's a binary to ASCII. Wait, ASCII to binary? I think it is. Remember, I always think it's backwards. I'm pretty sure that answer is correct, and though I often get it wrong in practice. All right, so I already know who that is. And Caitlin and Mateo. Good. All right, so Typeface didn't tell me who they are, and they're not getting their points. Apparently, they don't care. So, all right. I guess I'm going to stop this. I'll go up and see if anybody needs help in the lab. And next week, we have a guest going to talk to us about Penguin, a Linux distribution intended to run on Windows. I saw it in the news. We'll see what he has to say.